Great. Okay, so the first thing, I think it's not obvious, but it's types. Why do I say that types are useful for integrity? Well, because a type implicitly decides what is a valid value and what is not. For example, if your column is of type date, a date will be a valid value, and a number will not be a valid value, and the other way around. Okay, and also most databases have a lot of types that are very similar but have different size. Okay, so for example, these are pretty common. Tiny int, small int, big int, they're all integers, but tiny int is only 1 byte. So for example, the maximum value will be 255, and so on. MariaDB and MySQL in particular support signed and unsigned, which of course means, well, if it's unsigned, of course, values less than 0 won't be valid, but the maximum value will be more or less double, right? I think that most databases don't support this because these complicate things, because when you make a mathematical operation between two integers, it's not immediately clear if the result should be signed or unsigned sometimes. But anyway, yeah, this is the first feature. So let me ask Tianzhou, first of all, do you have some thoughts to share about this?
So I think the first one is kind of like not that controversial. So I would say, like, I guess most of the engineers, especially for the backend engineers, they all like types, right? But for the front engineers, they may not like types because they are using JavaScript. But yeah, so like so for me, I'm definitely on the pro side of the types, and even like for my MySQL or MyDB, I don't think they have a way to define the custom types. For like Postgres, so there will like the extra, like they have a enum and a domain, which you can define like the custom types, which like at the bare minimum, so that you can define a UUID type. Right. So other than like, because like so I think like when I develop the applications, I would really want to have a UUID type instead of like just like a matcha. So that will give me like extra validations. So for this, I'm not like so from my standpoint of view, I would just like use type if possible. But there is one thing I think it's also like open for debate. Yeah, like whether you want to use the matcha type or you just use like the text type. So in Postgres, it's kind of like a moot point, because like I think in the latest versions, there is no overhead of using the text type. But I'm not quite clear about my MySQL and MariaDB. So Federico, you may give your thoughts.
Well, unfortunately for MariaDB and MySQL, types are very loose. So for example, if you try to insert a number into a varchar column, in most cases, I think it will be converted and inserted. It partly depends on a configuration variable, which is SQL mode. basically it's a list of flags that can be active or not. Each flag basically makes your queries a bit more strict. Okay, for example, by using certain flags, you can force a string to be of the right length. Okay, so if you try to insert a long string into a small column, you will fail. Okay, but again, it depends on the SQL mode, because by default it's very, very loose. And in these examples, for example, strings can be just truncated, which is not good. The problem is that these decisions were taken probably in the 90s, and back then maybe it was okay. Nowadays a bit less. So we need to be careful about the configuration. You mentioned domains, and I think they are actually a cool feature, because they encourage you, or they help you to use types consistently. If you define an email domain and then you assign it to all email columns, all these columns will be the same. I mean, maybe it's not a huge problem, but it's probably a bit annoying that in most databases, this is not the case. If you look at different tables, the same data will be defined in a slightly different way, depending on probably which developer created the column. Most of the times it's not a problem for the application, but it's better to keep consistency. Right.
Yeah. So I have a follow-up question. So how often do you pass the strict flag to the SQL mode?
You mean the SQL mode?
Yeah.
Oh, well, for customers, I always advise to use the stricted SQL mode.
Mm-hmm.
Even if you set every flag, basically it will be slightly less strict than Postgres, for example, because, well, I'm sorry, I don't remember exactly what the differences are, but there are cases when it is a bit looser. But overall, it's good. I mean, invalid values will generally be rejected. So yeah, I always suggest customers to do it. But of course, the problem is that if they are already using MySQL and MariaDB, they are already writing an application. And if we change something like that, it could cause errors, which doesn't mean we shouldn't do it, because if there are errors when you set when you set the strict SQL mode, it means that the application has bugs. So setting it is a good way to find those bugs, but at the same time it's problematic, right? You can't make the change all of a sudden in production, because you could destroy the application.
Right.
Makes sense?
Yeah. So it's like so if you probably know, like when you search something, like you will find from the internet, like someone like says that their application just broken. Yeah, just because that SQL mode flag has been flipped. So from the not strict to strict. So then some queries just fail.
Yeah.
Right.
Okay, let's go ahead to the next. Oh, I'm not sharing anymore my screen, so let me share it again. Sorry. Okay, so oh, not null is the next thing, and it's one of my favorite. Because I have serious problems with null. I'll tell you why. But anyway, in SQL, null has two meanings, depending on the context, basically. It could represent an unknown value or a not applicable value. So, for example, when you have a user table and, I don't know, phone number is null, it doesn't mean that the user doesn't have a phone number. It means that we don't know it because the user didn't tell us, right? But for example, in a join, when you have all the columns of one of the tables set to null, it means that basically there is no match. Okay, the join found no match in that table. Okay, so in this case, they are actually missing values. So it depends from the context. By default, all columns can contain null, any type. But a column, of course, can be defined as not null. And I think it's a good idea to do so every time you can. For example, personally, I think that, I don't know, if you have a middle name column and the person doesn't have a middle name, you can insert an empty string instead of null. Also because null can easily bring to bugs, okay? Because you have to keep in mind that any SQL expression that involves a null will return null as a result. And when you use an SQL query to write the results into a table, this basically propagates, right? So you will write wrong data. So yeah, I don't like to use null when it can be avoided. But that's my opinion. So actually, I want to ask you, what do you think about it?
Yeah, so I think I'm almost with you. So the only thing I want to add is that, but I think it's like too ready to change. So I really think the default should be not now. Instead, like, because now for every mainstream database, when you create a table, like when you add a column to that, you need to explicitly specify not now. Otherwise, the column is nullable. I think it would be better if the database, when they did it originally, they say that if you want the column to be nullable, then you need to specify nullable. Otherwise, it's by default it's not null. So it's like the same philosophy is that we should try to avoid to have the nullable column unless there is really a valid case that way. So we need to have that null value. So, but I think it's just too late to change that. It's already part of the standard. So.
Yeah, I agree with you. And but I also think that the problem is partly cultural because developers are used to think that a missing value is null. Why? I mean, it can be an empty string, it can be 0, it can be a date in the past. The empty value can be expressed in any data type. So there is no need for null, usually.
Yeah. like this is it's kind of like avoidable because like for all like the not only for the SQL but for all like major programming languages, right? So we always have like a null value other than the empty value. So it's kind of like a reality.
Yeah. The only exception I can think, actually two exceptions, are for unique constraints, because
Yes.
typically you can insert any number of nulls. So, I mean, if you have a unique constraint on an email column, each email must be unique, but if an email is missing, okay, it's missing. Any number of emails can be missing. And that makes sense. You could implement a database without doing this. You could create an extra table for emails, but obviously it's not worth it. So in this case, I approve null. But and the other case is actually foreign keys, because when you want to have an orphaned row, the row with the ID of the parent row in the parent table can be set to null. But this is avoidable, to be honest. I mean, I understand it. It's more intuitive, but it can be avoided because you can create a special row in the parent row, which represents the absence of an object, right? For example, if the parent row is product, you can have a special row that represents no product, okay? And then there will be no need to use null. This is a frequent technique in data warehouse, right? Data analysts want to avoid using null because of the problems I already mentioned, and because it makes their queries even more verbose sometimes. So it's better to have a special row which represent nothing.
Yeah.
Cool. Let me switch again to my slides, and the next is actually unique. So, okay, for unique, I'll show you this example. Basically, you can, as I already said, you can have an email column, and you will have a unique constraint on this email. Well, in this case, the column is not null, so every value must be unique. If the column was null, as we already mentioned, any number of nulls will be admitted. Sorry. And the other example is just to show you that multiple columns can be in a unique constraint, just like in any index, basically, because at implementation level, unique is an index. So, well, in this case, this is probably a common case, right? Because here we have a relation table. It's supposed to be a relation between authors and books, a many-to-many relation, of course, because the same author might have written multiple books, but the same book could be written by multiple authors. So we have the columns author ID and book ID, and we could use them as a primary key, but I think it's not good in databases where the primary key is used to organize the table at the physical level for performance reasons. And anyway, it can still be good also to, even from a logical standpoint, it could be useful to still have an ID for this kind of relations. So I've shown in this example a separate primary key, and then these two columns, author and book ID, are part of a unique index. So we still guarantee that there are no duplicates. Okay. Any opinions or anything else to add?
Yeah, so I think I cannot think of like bad things about unique. It's kind of like a very valuable environment that actually you have. So the only thing I would add is that we need to be careful when we add a unique index to an existing tables. So even like the existing tables satisfy the unique requirements, but that will cause him to lock the table for a very long time. So I think that's the only thing I would add. So when we add a unique index, it needs to be very careful.
Yeah, it's a good point. It's a good point. Yeah, because locking is based on indexes usually. So yeah, I agree with you completely. Okay, so let's switch to the next. And the next is primary keys, which are similar, not identical. First of all, because from a logical perspective, a primary key is what identifies a row. Okay, and I wrote here in the slide, use surrogate keys to avoid problems with the constraints of a primary key. So, for example, in case you don't know, in case someone doesn't know, a surrogate key is an ID, okay, an artificial value that represents the row. The opposite is a natural key. So, for example, a natural key is when I use the email to identify a user. But this brings a lot of problems because, for example, the user might lose its email. It could have a different email in the future. Two users might have the same email for some reason. So even when a natural key feels right, usually it isn't. It's always better to have an artificial value as a primary key. And yeah, the next thing is, well, a primary key is similar to a unique constraint, but a row in the primary key can't be null. A value in the primary key can't be null. If the primary key consists of multiple columns, you can have some of the columns set to null, but not all of them. Otherwise, you wouldn't have a value for the row, for identifying the row. Make sense?
Yeah, so I think like overall the primary key, so like for example, for DB, if you don't specify, so if you don't explicitly specify a primary key, it will still add one. I think it's called like a underscore ID, something like that. So yeah, so
yes, but it's invisible.
yeah, right.
I mean, as a user, you can't access to it.
Right. So so I think overall, like it's just like part of like the database. So which still should exist, whether invisible or not. It's a good thing to have for every table because like quite a few internal operations or external database maintains tasks relies on a particular role and identify. Right. So in order to like make sure that a certain event is only being processed one time.
Yeah. Yeah. Actually, I forgot to ask you what you think about the second example I shown about NULL, the example of a relation table where I added an artificial primary key and I used book ID and author ID as a unique index. What do you think? I mean, do you agree with me that it's better to create a separate primary key, or would you just use book and author ID?
So I think there is like a quite popular article talking about that, right? So I'm on the side of like avoiding using like the column which has the real meanings as the primary key. So I would prefer to just say you say like a real ID, something like that. So I don't want to have my business logic coupled with like the real data, so that I lose some flexibility. So if in future my base logic changes, but if it's a primary key, I'm kind of like a student, so I have to kind of like copy over the entire table.
Okay.
Yeah.
And I'm curious. If I use Bytebase to handle my migrations, and I use the query route, I mean, I validate the migration. Will it issue a warning or not?
So in Bytebase, we have a review rules to say that if you don't specify a primary key, then it will actually report. But it doesn't have the capability to say that. So you need to use a certain type of columns as the primary key. So
Yeah, makes sense. Great. Okay, so let me switch to the next. We're going very fast. I thought we would be slower. Oh, foreign keys.
okay, I guess that may take a while.
I'm sure that some people were waiting for this. Okay, so first of all, let me show an example of foreign keys. Even if probably everyone knows what they are, but just to be sure. Okay, here we have this table, which is a book edition. So we have a book ID column, which should refer to the ID column in book table, okay? And we do this with a foreign key, of course. So we define foreign key. Oh, actually, it should be book ID. Sorry, this is my mistake in the slide. Sorry about it. It should, well, it should reference book ID. I wrote author ID, but it should reference author, I mean, book ID. And then we decide what happens if a row is deleted or updated in the parent table. Okay, the parent table is book, the child table is book edition. So on delete, we specify cascade, which means the corresponding rows in this table should be deleted as well. Okay, so you only delete a row in the parent, but if there are child row, they will be deleted too. And on update restrict is what probably makes most sense. It means that it shouldn't be possible to change the ID of a book. Okay, because if you do, all the IDs in the child tables should be modified too. So it's better to avoid. And could be obvious, but just to make sure that people understand this, foreign keys can point to the same table to be able to do a self-join. So for example, if the table represents a tree or a graph, it could be a good idea to use self foreign keys. Okay, it's not a technical term, I just made it up. Okay, and foreign keys can be circular, so table A could have a foreign key to table B, and table B could have a foreign key to table A. This usually creates problems, even if you are foreign key fans. I really discourage you to do this because really there are situations where they create problems that are hard to debug. Supported actions are no action, which is similar to restrict. The difference is no action is taken until the transaction is committed. Okay, so temporarily you are allowed to create inconsistency, but when you commit the transaction, the data should be correct and consistent. Cascade, well, I already described it. Basically, the update or the delete is propagated to the child tables. Set default, well, if the corresponding row is deleted, the columns in the foreign key are set to their default value, or to null if you use set null. Okay, so I won't tell you my opinions about foreign keys before you say yours. So what do you think?
Okay. Okay. So you want me to go first? Okay. Okay. For me, I always use the foreign keys when I start to build the applications. But I see like as the application grows to a certain point, inevitably like people will start to drop foreign keys. And that's especially true like for MySQL, for Postgres, because of the performance penalties. So like and especially like if you want to do like online schema changes. So for MySQL, if you are using Ghost, so it does not support foreign keys. So that then we kind of like, but we do still want that foreign key check. So we take out the foreign key and then we write our cron job to write the application code to check the foreign key integrity from the code side. So that's one. And the other thing is that although we are using foreign keys, I think there is one thing which is very dangerous: cascade. So there were like I see like the accidental data job, just because of the cascade. We specify the cascade in the foreign key. So when people like try to remove a row, they didn't realize it will actually remove all the rows from other tables. So it will cause that the accidental job. So that's two of my take. So how about you?
Well, I think there are a lot of different cases because every database is different and every workload is different. So, for example, if you have a highly critical database where you don't have a big workload, you don't have a big concurrency, for example, foreign keys can be good, okay? But when you have the opposite, when you have a database that has a lot of concurrency, a lot of writes to it, foreign keys can create problems. Because basically, when you start a transaction and you write some data, the way the database, I know you know this, but I need to explain to other people, of course. So when you make a write inside a transaction, the way the database guarantees consistency is putting a lock on the rows you modified. Or deleted, or the rows you are inserting. But if you use foreign keys, there are a lot of situations where these locks propagate. They propagate to the child table and to the parent table. And sometimes they do it recursively. Okay, because maybe you have a parent table, then a child, then another child, and it could propagate recursively. This can lead to applications that have a lot of locks and a lot of deadlocks also. A deadlock is when two different connections are trying to access something that is blocked by the other connection. Okay, so they are blocking each other basically, and there is no clean way to solve it. So when the database realizes what is happening, one of the two transactions will be killed, which is fine because a good application will be ready to retry a transaction, but you don't want this to happen too often, of course, and you don't want to have a lot of databases, a lot of locks in your database for performance reasons. So what is the alternative? Well, I think that foreign keys are placed in most cases just to be paranoid, which is fine. I mean, I'm not criticizing this mindset, but basically every time there is a theoretical possibility that data becomes inconsistent, a foreign key is placed. And the database will do a lot of checks every time you insert rows, delete rows, blah, blah, blah. But in practice, maybe there are just a few cases when inconsistencies become possible. And what are those few cases? Well, only developers know that. They write the application. They know when data is written what is being written and so on. So they understand what can go wrong. If you leave this decision to the database will basically assume that anything can go wrong always, but it's not the case. Okay, the developers know when to do checks and how, and probably it will be just a few cases. In most cases, they don't need to add a lot of queries to be super sure that data is correct. What do you think about this? Sounds crazy.
Yeah, I will add another benefit of foreign keys, which is I think it cannot be replaced by other places. So I think foreign key does serve a very good purpose for documentation. So
yeah.
So
sorry.
Yeah. So like if I can see like so when I like learn other applications schemas, so if very like the foreign keys defined, it will help me to understand the data models, the relationships between different tables. So I think that's something pretty valuable to me.
Now, I think that documentation is a great point. I know that a lot of tools use foreign keys to automatically draw entity relationship diagrams. So it's good to have them, but some technologies, some databases allow you to create foreign keys and disable them. For example, MySQL and MariaDB allow you to disable them globally. So you can't disable a single foreign key, but you can disable all foreign keys. And I would suggest to do it, actually, if you can. I understand it's not always possible. In most cases, developers will need at least some foreign keys. Okay. What I said before remains true, but I understand that a lot of practical problems might arise, and sometimes you simply want to have at least a few foreign keys, and that's fine. If they're not many, it's fine, usually. But if you could avoid any foreign key, you could basically do this, create them and then disable them. I know that some database technologies for data warehousing even don't support foreign keys, or they support them, but they don't enforce them. So they are only for documentation. For example, Amazon Redshift allows you to create a foreign key. When you look at the table, you understand where it points, but you are totally allowed to insert invalid data. Of course, data warehousing is a special case because they need to insert a lot of data, a huge quantity of data, and they need to do it fast. So and also it's for analysis of big quantities of data. So when you make calculations or aggregations on a lot of data, you don't care too much if there is a small error. So it's a special case, I understand that. In OLTP, well, it depends. If scalability matters for you, and if you can, I really suggest to get rid of foreign keys and maybe only use them for documentation.
Yeah, then probably it's just like the valid use case to in MySQL to disable foreign keys, but still have the foreign keys on the table, just to serve the documentation purpose.
Right. Right. Okay, so let's go to the following. Sorry. Okay, so checks. A lot of developers don't know about checks. Isn't it amazing? I mean, checks are just conditions that you can add to a table or to a column. Okay, so in this case, okay, we have a customer table with first name, last name, and I'm using check to verify that last name is not an empty string. Okay, so it's a way to validate values with an SQL expression. And here I've listed some examples just to show what you can do with checks, right? So, for example, you can use check to verify that % is a number between 0 and 100, and real price is somewhere between minimum and maximum columns. And this is a bit more complex, actually. I did it on purpose. I wanted to show that it doesn't have to be a trivial check, right? In this case, we want to check that if first name is present, sorry, the opposite. If first name is not present, middle name must not be present. Okay, because you can insert the first name only or the first name and the middle name, but it doesn't make sense to only insert the middle name. Then we check, for example, that a date is older than another, and the email is valid. Here I used like pattern, which is not really precise. I mean, I could have used a regular expression. It would have been much more precise, but come on, a trivial check would be enough. And the last one, well, just checks the length of a string. So if we have a credit card string, we can check that the length is 16. So, do you like checks?
So the only, I think in my career, I think I see one place, so I won't see one place that the company don't want to use checks. So the reasoning is that because the checks is not that expressive, so they cannot put all the check logic inside the databases. So then there are some logic inside databases and some have to be enforced on the application side. So they decide to actually to manage it all from the application side. So that's the only case I see that why like people may not want to use checks. But other than that, I think it's kind of like a neat feature. Yeah. So.
Personally, I think that checks are very interesting because, I mean, in a create table statement, you define your data, right? You define the data types, which columns you have, and so on. It's good to also define what is valid and what is not. You have everything in the same place. And there are some cases where it can be particularly useful because Okay, maybe it doesn't happen too often, but I saw cases where multiple applications could access the same database, right? And if it happens, they all should validate the data. And it's a lot of code duplication, right? It makes no sense to me. It would be better to have the validation in a single place, in the database itself. And it can be used to do very good validation after all, because SQL expressions are more than sufficient to do it. And every check has a name. And when you try to violate a check, you will get an error message with the check name. So the applications will have to check with, I was trying to find another word, but they will have to check with which name appears in the error message, and they will return the right error to the user. I think it's a perfect solution. Also, I think it's even simpler. Probably writing these checks directly inside the table definition is simpler than implement the validation on the application side. So, okay, I criticized a bit foreign keys, so it might sound strange that I advocate checks, but why not? From a performance perspective, they are totally okay. They are very simple operations. They don't lock anything. So yeah. What do you think?
Yeah, so my point is like mainly, I think I also encounter by myself if I want to do some check, which involving several different columns, and it's not like simply like the format or range check. So it becomes quite complex to actually to write the check logic. So it have to be so have to kind of move that one to the application side. So
yeah, thanks for pointing it out, because you made me remember that I forgot one use case for check. I mean, one more reason to use checks, because sometimes you only modify a single value in an existing row. But someone else could be using that table. I mean, okay, maybe you use transactions properly, but still there can be strange situations in which someone else does something more or less at the same time, and then values become inconsistent. But if you have the validation in the table itself, it will be impossible that two columns become inconsistent with each other.
right.
So yeah, you made me remember that I forgot this case, which is probably important for some people.
Yes.
Great. So let's go to the next topic. Oh, sorry, I should share my screen again. I need to find a faster way to switch between the screen and and the next. Oh, actually, this is not used often. Maybe it was used in the past. I don't know. Basically, here the technique is writing a view and add this syntax with check option. Okay, so a view is just a saved query, basically, right? It's a query with a name. you can use it as if it was a table, but it's actually a query. But you can insert data in a view. Not always. If it's a join, probably you can't. If it's a group by, probably you can't. But if it's a simple query, you will be able to insert the data. But basically, the validation here is we are selecting data with a where clause. Okay. We have these conditions, and by default, if this view is writable and you insert a row into this view, by default, the row will be accepted even if it doesn't match the where clause. But you can use this syntax with check option, and then basically you can have a view built on a table with the only purpose of defining which data can be accepted or not accepted. Okay. It's not the cleanest solution ever. It's a bit complex, probably, and I need to mention one thing. If you read data from such a view, in some databases and in some cases, basically you won't be able to use the right index, and the query will be slower than it should be. It's not always the case, and it also depends a lot from the technology you're using. But I saw it happening even with Postgres, which has a very advanced SQL optimizer. So if it happened with Postgres, I would imagine that it can happen with more or less any database. So it's not a very widely used technique, but I wanted to mention it because some people do it, and yeah. What do you think, Tianzhou?
So I actually don't have much experience with this, so I cannot provide my input here.
I mean, anyway, I'm not really suggesting to do it. It's something I've seen, and I wanted to mention it and let people know that it's possible. I don't have strong opinions on this, but probably it's a bit overcomplicated, maybe. What do you think?
Yeah, I still need to, I guess I also need to study that one. So I don't think I've ever used it.
Okay, so let me go to the next. Okay, so triggers. Some people love triggers. This is a simple example of how a trigger can validate data. But first of all, actually, I should explain what is a trigger. Well, a trigger is just an SQL piece of code. Well, of course, SQL with some procedural extensions. Okay, so you can use if, while, and so on. But it's a SQL piece of code where you can run something before a row is inserted or updated or deleted, or after it is inserted or updated or deleted. Okay, and the key characteristic for us is that you can produce an error. In this case, I used the signal statement, which is from MySQL and also some other databases. I think that Postgres uses something else, SQL Server uses something else, so the error syntax is different from database to database, but it doesn't matter. I think you understand the point. We are checking if date of birth is valid, and if it is not, we produce an error. Okay. In this case, the date would be from the future, and we say we don't sell to time travelers. Anyway, can be. Oh well, sorry. It's the only slide about triggers. Of course, you could do something more complicated than this. You could, for example, use a trigger to validate that if you are inserting a row in table A, there must be exactly 3 matching rows in table B. You can't do that with foreign keys, for example. So, but the problem is this could be a bit complex, right? Well, anyway, I will tell you my opinion later. Actually, I should ask Tianzhou, what do you think about using triggers for validation?
My point here is that like the most common cases is to generate like the timestamp, or like to like so I often use triggers like to like say to update the last updated person, because like I want to record like who updated the row the last times. So in such cases, I don't think there is any other better way to do that. So I would say it's kind of like a good thing. So but I don't use it that often because I don't see like a lot of cases need to use triggers, to be honest.
Okay. Well, I've seen people doing it, honestly, and maybe in the past I even recommended to do this in some special cases. It's not something I would recommend a lot now, honestly. I think triggers can be useful, well, not just for validation, they can be useful in general. For example, if you want to log the changes that happen in a table, a trigger is a very good way. And sometimes, in some cases, they are even okay for performance. They don't create problems. But a lot of times they do create problems because they have the same problems I mentioned for foreign keys, but they are a bit worse because a trigger allows you to write some queries in the trigger, right? But when you access data and you do it inside a transaction, probably that data will be locked. And it will be done in a less efficient way compared to a foreign key because a trigger is more generic. I mean, it has more work to do. It has to read your SQL queries and run them. A foreign key is a bit more optimized than this. It only does very specific things. So yeah, I don't think they're a good idea for most cases because they don't scale well, which maybe is a pity because some complex validation could be possible only with triggers, maybe, but well, still, they can be too problematic, right? Okay, let's quickly switch to the last topic, I think, which is, oh, sorry, I I didn't share my screen. Let me do it. Okay. So the last topic, which is store procedures, which is very related. But I will tell you why in a second. Okay, store procedures can be used for data validation too. And here you have an example, well, a trivial example, because this is a procedure written specifically to validate data. So basically what it does is it counts, oh yes, the number of team members in your team, where team ID equals new ID, and the team leads. Okay, the team members should be more than one, and the team lead should be exactly one. If one of these conditions is not satisfied, it will return an error. So they are more flexible than triggers, because a trigger is only filed when a certain event happens. But you can decide to call the store procedure whenever you want. Even from a trigger, you can call it store procedures. So you could theoretically have some triggers that call this procedure. So yeah, this is the technique. But let me ask Tianzhou, what do you think about it?
So for me, I would avoid stored procedures as much as possible. But there were two cases which is actually you cannot avoid it. So the first case is for the performance reason, right? So if you put on the application side, so there will be like round trips. You like issue multiple SQL statements. But if you just put it into a stored procedure, then it will just be run inside the database. So there will be a huge performance difference. If you have a very long SQL, like a few SQL statements to avoid the round trip. And the second case of using stored procedures is to avoid the duplicate code. Because like if you are moving the logic outside of the database, and if you have like different clients written in different languages, right? So you need to duplicate the logic in Python, C++, Java multiple times. So I think that's the two strong cases that sometimes that people have to put the stored procedures. So, but for me, I always try to avoid the stored procedures as much as possible. So for the second case, in my case, I always like only have one single backend programming language. So I will not have like Ruby, C++, Golang, Java. So I will only have one. So I will not have the program of the code. But for the first one, it's just kind of inevitable that you have to put some like core logic inside the stored procedures to improve the database performance. So.
I think these are very good points. In general, I'm not against stored procedures, to be honest. Well, of course, it depends from case to case. If we talk about MariaDB and MySQL in particular, I don't like to use them if they are supposed to be called by the applications very often, because they are not fast. They are much slower than they should be. So MariaDB is improving in this, but still it's not very fast. More generally, well, I think they have pros and cons. One thing that people often don't consider is that if you have a database architect that designs the database, maybe it does it in a very optimized way, but as a consequence, maybe the structure is not very obvious to the developers. Okay, it can happen sometimes, right? Sometimes developers have to find out where to put some data, how, and blah, blah, blah. Well, in that case, the person who designs the database could write stored procedures to perform the basic operations. And the developers would just have to call them. And when you say this to developers, usually their initial reaction is, no, never. But this tends to change when you tell them that, after all, it's just an API for them. A stored procedure libraries can simply be an API. If they don't have to maintain it, they will simply call the procedures, use the result, and nothing else. It shouldn't be a problem. What do you think?
Yeah, so you remind me another point that why I don't like, so I try to avoid the stored procedures, because it's harder to maintain the stored procedures compared with the code. So especially if I want to make some scripting changes. So it's harder to actually change the stored procedures. Then I can change the application code, because for the application code, so there is like a full CI/CD cycle. Like I can go back, like I can do a phased rollout. But for the stored procedures, normally it's just like a single point of failure, right? So if I just have a bad change to the stored procedures, and all my application will fail. So there is no kind of like the grayscaled release or the gradually release thing if I put it into the into the databases. So.
Well, but yeah, I mean, it's a single point of failure, just like any piece of code, after all, right?
Right. But if I put the code inside the application, I can route the application gradually.
Right.
So,
yeah.
But for the database, it's like 0 or 100%. So
yeah, this makes sense, of course. Yeah, it's a good point. It's a good point. Yeah, I think it was the last topic. Actually, we probably exceeded our time, right?
Yes.
Oh.
So we are like 17 minutes late, but I think that's it's still fine in terms of editing the recording.
Any questions from the audience?
Sorry?
Any questions from the audience?
Anyone?
No questions?
I don't know. Stacy? Are there questions?
I think that we have some question.
Yeah, I think there is a question. Federico, maybe you can answer that.
Oh, yes, sorry, I wasn't able to see it. Yes, but no. I mean, it depends which database you're using. I know for sure that in Oracle, yes, they can be activated by create table or alter table, but probably in most databases, no, I don't think so. Yeah.
More questions? Wait a bit.
Someone raised the hand. Okay.
No one else?
I think someone just tested the option of raising a hand. Because I don't see anyone.
Okay.
All right.
Well, we talked a lot, so maybe we already said everything. Well, if there are no questions, I think we can close it. Oh, this is for us, actually. Can Vettabase help with migrations from Oracle to MariaDB? Yes. Contact us, please. We can.
Any other questions? It's the same question that was asked at the start.
Yeah, but we already answered. I don't think we should. Maybe it was a mistake.
Yeah.
Can I force a column to contain a list of 3 elements? Like a list, like in a string that is a list? In that case, yes, you can use a regular expression, I guess. Or just like a like button should be enough.
Yeah. To add, if it's for Postgres, you can define an array type, and you can use the check syntax to check that it only contains three elements. But I don't think that's available in MySQL or MariaDB.
Right.
So if you don't have any other questions, I would say that we need to wrap up.
Okay. Thanks, everyone.
Well, thank you, Tianzhou. It was very interesting. Thank you, everyone.
Yeah.
And thanks to Federico.
Okay, thanks. Till next time.
Yeah.
Yeah. Bye-bye, Stanley. Bye-bye, Federico.
Bye-bye. We'll send the slides and the recording to everyone via email. And our next webinar will cover user-defined functions in Go or MariaDB. Hope to see some of you there.